Hello, good morning. I am SEEMA GARG, Associate Professor in Chemistry, SPC Government College, Ajmer. Today, video 89, lecture 27. It is for BSc Part 1 Organic Chemistry, Paper 2, Unit 2. Today, we will discuss chemical reactivity of dienes. Means alkadines की आज हम रासायनिक अभिक्रिया के बारे में देखेंगे. Alkadines, as we had classified in three categories, isolated, cumulated, and conjugated dienes. So we will see the chemical reactivity separately of each. Reactions of isolated dienes. Isolated dienes, it gives similar to alkanes reaction, because the pi electrons is localized on their position, so it will gives like alkenes. Addition of halogens. Halogens are added to 1,4 pentadienes. 2 times it will give 2, 1, 2, 4, 5 tetrabromopentane. Addition of hydrogen halide. The addition of hydrogen halide HBr and HCl to isolated diene involves the two independent addition reaction, each according to Markovnikov's rule. When 1,4-pentadiene HBr 1 mole is added, it will give 2-bromo 4-pentane. When 2 moles of HBr is added, it will give 2,4-dibromopentane. Mechanism, as usual, like alkenes, it will first protonatate and gives a stable carbocation, and then anion nucleophile is added to the reaction. It is again 2 times and it will give 2,4-dibromopentane. Reactions of cumulated dienes, allenes, addition of hydrogen halides. See here, it is again according to Markovnikov rule, addition of halogen. See here, 2 times when we are adding halogen, we will get 1, 2, 2, 3 tetrabromopropane. Hydration reaction, it is again according to Markovnikov's rule, and after rearrangement it will ketoenol to, means it will give acetone. Catalytic hydrogenation, when hydrogenation is carried out in presence of platinum or palladium catalyst, it will give normal propane. Ozonolysis, 2 moles of ozone, it will give ozonide, and then on hydrolysis in presence of zinc, it will give ketone, corresponding ketone. This reaction is useful for determination of structure of allenes from the isomeric alkynes. Rearrangement. Allene can be rearranged in presence of strong base. It will convert it to propyne. Next, reactions of conjugated dienes. Electrophilic addition reactions. In presence of chlorination, carbon tetrachloride, it will first give 3,4-dichloro-1-butene, 1,2 addition product, and 1,4 addition product, 1,4-dichloro-2-butene. This preparation of means production of this 1,2 addition product and 1,4 addition product depends upon the temperature. So see here how this 1,2 addition and 1,4 addition product is occur. When protonation is done, then it is form allylic carbocation. It is more stable, and primary carbocation is less stable. This allylic carbocation, this is electrons are dispersed to the nearest carbon, and after dispersion it will give 1,2 addition and 1,4 addition product. It depends upon the temperature, how it is. Suppose this reaction is carried out at lower temperature, it is at minus 80 degrees centigrade temperature, then we will get 80% 1,2 addition product and only 20% is 1,4 addition product. And this when this reaction is carried out at higher temperature, at about 45 degrees centigrade temperature, at that time we will get 1,2 addition product is only 15% and 1,4 addition product is 85%. So this 1,2 addition product is known as kinetic product, whereas 1,4 addition product is known as thermodynamic product. Free radical addition reaction. When trichlorobromocarbon is reacted in presence of peroxide, it will again give 1,2 and 1,4 addition product mechanism. First, this peroxide will convert it into alkyl free radical and carbon dioxide, and this alkyl free radical will react with bromocarbon, and it will give trichlorocarbon free radical. This trichlorocarbon free radical is reacted with 1,4-butadiene. It forms two types of free radical. As we know, this secondary free radical is more stable compared to primary free radical. And this trichlorocarbon, bromocarbon is reacted and it will give 1,2 addition product and 1,4 addition product. Cycloaddition reaction, Diels-Alder cycloaddition reaction. This diene, when reacted with a different type of dienophiles, it will give cycloaddition product, corresponding cycloaddition product. Polymerization. Polymerization of conjugated diene may involve 1,2 addition or 1,4 addition of one monomer to another monomer. So n moles of 1,3-butadiene, when 2 n moles of butadiene when reacted, it may give cis polybutadiene or trans polybutadiene. Polymerization can also be represented as a general reaction. Natural rubber. Natural rubber, isoprene, 2 units of isoprene when polymerized in presence of peroxide, it will give natural rubber cis configuration. When isoprene 2 units are polymerized in presence of peroxide by using Ziegler-Natta catalyst, it is of triethyl aluminum titanium trichloride complex. In that catalyst, it will give trans configuration, and this is also known as Gutta-Percha. And Gutta-Percha, this trans configuration polymer, it is harder and more brittle than the natural rubber. It is also known as a synthetic rubber. Other synthetic rubbers are Buna. Buna means butadiene, and in presence of sodium polymerization, it will give Buna. And when we are stirring in presence of means 75% butadiene and 25% styrene is reacted in presence of sodium, it will called Buna-asp rubber. It is used for in making tires, shoe soles, etc. Buna 75% butadiene and 25% nitrile, acetonitrile. When it is polymerized, it will give Buna N. Neoprene rubber. Chloroprene unit, when polymerized in presence of peroxide, it will give neoprene. Vulcanization of rubber. The elasticity of the natural and synthetic rubbers is satisfactory only within a limited temperature range. It becomes stiff in cold while too sticky in hot. Rubber's elasticity is improved by vulcanization. In vulcanization, a chemical reaction occurs in which the neighboring polyisoprene chains become connected through reactive allylic position of covalent bonds. See here the sulfur breeze. So 3% of sulfur is added for vulcanization. So that's all for today's lecture. Thank you very much.